Hello, Honors Chemistry, and welcome to the lecture covering through section 10.5 in your outline. What we're going to do is we're gonna focus on how to draw Lewis structures. We're going to go through our rules, make sure you guys are sure on what the rules say and what to do about them. Then we're just going to do several practice together. We just have to practice. Practice is super duper important. All right, so as we talk about this, just to point out a few things, right? When we talk about Lewis structures, right? Lewis structures, what could we call a Lewis structure? Right. A Lewis structure is just a bonding model, right? This is a model for what that helps to explain the observations that we see about how molecules behave, right? So that's not necessarily the end-all be-all, right? And it's definitely not 100% correct. But it is something that helps us to explain the things that we see about how atoms behave, okay? So, step number 1 says we're going to write the correct skeletal structure, right? That's the wording from your book. What that really means is we're going to arrange the atoms on our paper, being thoughtful about which should go in the center. Most of your structures are going to be composed of a central atom to which everything else is bonded, right? The exceptions would be larger organic molecules. But in terms of what goes in the center, right, if it's an organic molecule, carbons are going to be at the center, right? Either there will be a central carbon, right, or carbons will make up our backbone, right, like we've talked about long chain hydrocarbons, right? So carbon will make up the backbone, all right? Beyond that, if we're thinking about our periodic table, right, the ones that go in the center are going to be the ones that are more metallic in general, right? So meaning things that are further to the right, things that are further to the metal side, right, which would be the left. So further to the left or further down are going to be the things that tend to be the central atoms, right? So the atoms to which everything else are bonded. Okay, moving on, rule number 2 says we're going to count the total number of valence electrons. So why are we going to count valence electrons? And why only the valence electrons? Why don't we care about everything else? For example, for beryllium, why would it be 2 instead of 4? Right, because going back to definitions we've been talking about all year, right, valence electrons are the only ones, okay, they're the outermost ones, right, which means they're the only ones available for bonding, right? They're the only ones available for giving, taking, or sharing, with the goal being to, right, to fill the octet. And why are we filling octets? Or why 8? Right, because it goes back to your S and P subshells, right? So anyway, we're going to calculate our total number of valence electrons, and then we're going to distribute electrons, and we're going to form bonds to the central atom, and then we're going to fill our octets, right? Here, though, there should be a little special mark here. Is that how they all go? Are they always going to have a central atom to which things are bonded? Right. First, we really need to ID the type of compound, right? Because if it's ionic, is there going to be a sharing of electrons? No, right? If it's ionic, then we're just going to make cations and anions. Yeah, that's what we'll say. Make cations and anions, right? If it's molecular, then yeah, we're going to share and form bonds, right? So it's important that we are attentive. All right, next rule says that we're going to form double or triple bonds as needed by redistributing electrons, right? So 4 only comes into play if 3 doesn't work, right? If we distribute all of our electrons and it turns out we can't fill octets, then we know something else has to happen, and that's we're going to form double or triple bonds. And the last step, always, 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 double check, okay? 9 times out of 10, if we do our double check, we're going to get the structure right. Kind of like when we do our conversions, right? The milliliters to liters, for example, at this point is so easy, and you've done it so many times, but if you write it, you'll probably never get it wrong, right? Anyway, so yes, double check by counting your electrons and checking your octets. So basically, we're going to go back and double check steps number 2 and 3. All right. What we're going to do is we're going to stop this video here, and we will pick up in the next video with practice. All right, thanks for listening. Be good, and I'll see you soon. Bye.